Hello everyone, welcome to CH for us. Today we'll be learning oxidation with DDQ where insertion of oxygen is seen. So for example, we'll be taking this compound which is reacting with 3 equivalents of DDQ and it will give us a structure called as coumarin. So in coumarin, we can see ring closure occurring here as well as an oxygen is inserted. Now we'll see the mechanism. So the compound will be reacting with 3 equivalents of DDQ. So here this compound will react with the first equivalent of DDQ. In DDQ we can see bond delocalization takes place, giving us a structure like this. And in this compound the alpha hydrogens are present on this carbon, right? So one of the alpha hydrogen will come out as H minus and a positive charge will be formed on this carbon. This hydride ion will go and react with the positively charged oxygen, giving us phenolate ion. As this carbon is positively charged, this double bond will be shifted here, and when the double bond is shifted here, this carbon will be getting a positive charge, and when this carbon gets a positive charge, the bond between oxygen and hydrogen is shifted here, forming a double bond, and this hydrogen will leave as H plus, and this H plus will be reacting with the negatively charged oxygen, giving us 2,3 dichloro 5,6 dicyanohydroquinone. And after the delocalization of these bonds, we'll be getting a structure like this. Now, in this structure, electrocyclic ring closure takes place. That is, the ring closure is an important step in this oxidation of DDQ. So, this bond is shifted here, this bond is shifted here, and this bond is shifted here. And we can see ring closure occurring in this compound. Now this compound will be reacting with the second equivalent of DDQ. In the second equivalent of DDQ, bond delocalization takes place, giving us a structure like this. And in this compound, one of the alpha hydrogens will be removed as H minus and this carbon will be getting a positive charge. The removed H minus will form a bond with the positively charged oxygen, giving us phenolate ion. Now the negatively charged oxygen in phenolate ion will bond with the positively charged carbon of this compound, giving us a structure like this. Now this compound will be reacting with the third equivalent of DDQ. Now in this third equivalent of DDQ, bond delocalization takes place, giving us a structure like this. And in this compound, the alpha hydrogen will be removed as H minus and the carbon here will be getting a positive charge. And this H minus will go and bond with the positively charged oxygen, giving us phenolate ion, and the negatively charged oxygen of that phenolate ion will form a bond with this positively charged carbon, giving us a structure like this. So here in this step, we have to insert the oxygen into the compound. For that, first this bond has to be shifted here, forming a double bond between the carbon and oxygen. This carbon will be now negatively charged. So to neutralize the carbon, the oxygen will take the bond and will be removed as phenolate ion. After that we'll be getting coumarin, the desired product. Now the O minus of phenolate ion will form the bond with H plus and the positively charged carbon will form a bond with OH minus during hydrolysis and will give us two molecules of 2,3 dichloro 5,6 dicyanohydroquinone. So this is oxidation with DDQ where we can see ring closure and insertion of oxygen taking place.